Alright, hello everyone. So in this video I'm going to solve some easy linear equation problems. So let me do the example 2 in the note. So we have this differential equation, and first thing we need to do is, as you know, we have to convert this differential equation into standard form. And this differential equation is already not in the standard form because we have a coefficient who is not 1 for dy over dx. So let's divide by x to make that coefficient 1. So we can rewrite the differential equation when 2y over x and x cubed over x is x square. Of course, x shouldn't be 0 when you're dividing by x because you cannot divide by 0. So we can rewrite the differential equation just like that. Okay. And now, since we have the standard form, the next thing we should do ideally is to identify our p correctly. Now, p is the coefficient for y term. So, coefficient for y term here is 2 over x. That is my p. Now then, after you identify p, the reason we identify p is to find the integrating factor. Integrating factor is given by e to the integral of p on the exponent. So integral of p is 2 over x, and then let's take that 2 outside the integral because it's a constant, makes our integration easy. So this will become like e to the integral of 1 over x is natural log x. Now this is my integrating factor. But once you find the integrating factor, one thing you should always do is take a pause and think whether you can simplify the integrating factor you found into a much simpler function or not. Okay, so can we simplify e to the 2 ln x? Well, we can. In the previous quiz, you saw some preparation for this point, right? Now, using logarithmic rules, we can rewrite this integrating factor as e to the natural log x square. Now, how did I get x square? I took this 2 to the inside of natural log by logarithmic rules. So we get e to the natural log x square. Now by again, as we saw in the last quiz, that we can write this e to the natural log x square as x square again by logarithmic rules. So this integrating factor is much better than what you had before. And you cannot escape this, okay? So if you can simplify your integrating factor, you must do it, okay? Otherwise, you will have a hard time solving the rest of the problem. All right, now we got our integrating factor. So once you got your integrating factor, what you do is you take your standard form and then you multiply the standard form by integrating factor. So let's multiply the standard form, which will give us x square dy over dx plus x square times 2y over x is equal to x square times x square x to the 4. Okay, now here we can little bit simplify, especially, oh well, no, we already have a nice, my bad, I take that statement back. So we multiply the standard form by x square. Now we know the whole point of finding a special integrating factor is to rewrite this left hand side as the derivative with respect to x of integrating factor times y, right? So let's rewrite that left hand side. Well, we got to this point, okay, and now what we are going to do is, okay, we have x to the 4 on the other side. Well, we have to multiply both sides by dx, right? So we multiply both sides by dx. Now we do an integration. So if you do an integration on the left hand side, what you always get is integrating factor times y. We saw that in the previous example and we saw that in our method too. So when you do the integration here, you should get x square times y, and if you do the integration to x to the 4, you should get x to the 5 over 5 plus c. C is an arbitrary constant. Well, we can divide the whole thing by x square because we want the explicit solution. Well, we divide by x square. So y is x to the 5 over x square is x to the cube, right? Plus c over x square. Now this is my explicit solution for the differential equation in example 2. Okay, so let me do the example 3 also. Now all the examples that I do here are easy examples. Okay, so the example 3 is x squared dy over dx plus 4xy is equal to 2, I believe. Let's verify it again. Yes. Now again, what is the first step? Make sure your differential equation is in standard form. So here it's not in standard form. So what I do is I divide by x square the whole differential equation. So when I divide by x square, let's do it. This cancel out. So we get dy over dx here. Here 4xy over x square and 2 over x square. Again, we are dividing by x square, assuming that x square is not 0. Okay, that's a mathematical idea and mathematical sense that we should have. When you do the division, you shouldn't be dividing by 0. Anyway, so we have this standard form right now, and well, I can simplify this furthermore, right? I didn't see it. X and x cancel out, so this should be actually 4y over x. Right. Now, when I look at this, my p is 4 over x, right? The whole point of finding p is to find the integrating factor. So mu is e to the integral of 4 over x. Let's take that 4 outside the integral, so 1 over x dx. So let me pause a minute here. One of the most common mistakes I have seen when I'm grading these problems is that students often forget the e part, the exponential part, or students just do the integration on the exponent and they drop out the e. Okay, that should not happen unless you use logarithmic rules. Okay, so be careful, have a good understand what is mu is. Now when you do the integration here, we get e to the 4 natural log x. Now what I was talking about is most of the times students forget e and write integrating factor is just 4 ln x. Okay, right. So we saw by logarithmic rules, and you know now you have to pause a little bit once you found your integrating factor. Think whether you can simplify it or not. Well, we cannot simplify our integrating factor here, my bad. So we can write this as e to the natural log x to the 4, and again by logarithmic rules we can rewrite this as x to the 4. So that's a much better integrating factor, right? Good. So we found our integrating factor. We have our standard form. So let's multiply the standard form by integrating factor you found. So when I multiply by the standard form, what I get is x to the 4 dy over dx plus x to the 4 times 4y over x is equal to, so 2 over x square times to the x to the 4 means 2x square, right? X square and x4 simplifies out. All right, now we know the left hand side reduce into derivative of integrating factor times y. Okay, that we know for sure, and the right hand side is 2x square. Now the same steps, we multiply both sides by dx and then we do an integration. So when we do the integration on the left hand side, you saw that what we get is integrating factor times y always. And then when you do the integration on the right hand side, it's 2x cubed over 3 plus c, an arbitrary constant. Now to get the explicit solution, let's divide the whole equation by x to the 4, assuming that again x to the 4 is not 0, right? We cannot divide by 0. So if you divide by x to the 4, first term if you divide by x to the 4, x cube will cancel out, so we'll left with 2 over 3x, 1x will left on the denominator, and c over x to the 4. And this is my explicit solution for the differential equation. Now example 3 and 4, 2 and 3, my bad, in the note are easy examples just like I did here. Now take the next quiz and watch the next video to see what kind of questions that I consider to be a little bit challenging in this section, and definitely you need to know how to solve those problems. Okay, then see you in the next video. Thank you.